All right. One of the aspects that we would like to do is this on page 311. Follow along should you choose. And that is, okay, on page 311, the practice problem number 1. We had done number 2. So for number 1, it's got 2 parts to it. It says, okay, so laughing gas, nitrous oxide, which some of you have been inhaling, is sometimes used as an anesthetic in dentistry. Okay? It is produced when ammonium nitrate. So again, how many of you would struggle if you just saw ammonium nitrate where they're not giving you the formula for it? Okay? Page 311. And it's talking about ammonium nitrate. How many of you would have a problem writing that out? The ammonium nitrate. Okay? So the problem with that is if you don't have it wrote out, notice last chapter, whether it was balancing the equations, it would just you just get the equation wrong. Okay? But in this case, with the writing the wrong equation down, there's probably, I'm just speculating, maybe 4 more steps after that, maybe 5. Everything you do and beyond that, it's probably going to be wrong, and that's why we put so much stress on that, writing out these equations last semester, and why we spent time on it, especially in physical science. Maybe you do or don't remember that when you were a freshman, and the first time you had seen that, maybe thought this is awful. Maybe yes, maybe no. I really don't know. So this ammonium nitrate, okay, so what happens is, what's that doing? It's the only process or only compound on the left side. Then you have an arrow which is telling you that that ammonium nitrate is doing what? Yeah, it's decomposing into 2 substances, the nitrous oxide and then your water. Okay, so how many grams of ammonium nitrate are required to produce 33 grams of nitrous oxide? Okay, so even though they have given you the equation per se, you still need to do what? You still need to be able to balance it. That's right. Okay. So what that means is we've got our ammonium nitrate. Okay. And then you correctly said we've got that decomposing into 2 substances, one being the nitrous oxide, and then the other is just water. It doesn't do you any good to break that water molecule apart into HOH because you don't have a hydroxide over here. Okay? So looking at that, just because of human nature, what do you think is probably, now this is just my estimation and some of the experiences that I've seen, what's perhaps the number one problem that students may forget about on the left-hand side, as opposed to on the right-hand side when it comes to the nitrogen? There's 2 of them on the left. Okay? And the reason I say that is typically when you balance these, we would keep our polyatomic ions together. But that won't do you any good in this case because remember, there isn't a hydroxide over there, or excuse me, over here. We don't have a nitrate over here, and we don't have an ammonium over there either. N2O, isn't it? Yep. I was just seeing if anybody's paying attention. So now, here I sit here and say, you need to get the equation right off the bat. Write the wrong thing down. Okay. So with that, oh, they do balance it for you. Okay. 1, 1, 2. So we just have that 2 here. Now everything is balanced. Now The next thing you're probably going to want to do then is possibly write down what you're starting with. In this case, we have got 33. How many grams of ammonium nitrate are required to produce 33 grams of this? So we want to produce that. Well, what is it that we need to start with here as far as a mass is concerned? Okay, so with that, how many steps of a problem is this in our dimensional analysis? 2, 3, or 4? 4. It's 4 steps. Okay, so is this one that you want to work on your own, or do you want to work on it together? Okay, so with that, I get to look at this and say, so letter A should be 60 and letter B should be 27. Okay, so keep that in mind. Somewhere around 60 is what we're supposed to get. So 33 grams, okay, of N2O. All right, said there's going to be 4 steps to it. Okay, so cancel. This is old news. Grams per mole. Okay, and N2O. 28 and 16. That's what 44. Is my math correct? Okay, so probably 44.02. All right. Now, no surprise. This next step is so important, and if you don't understand that yet, you're not doing yourself any favors by saying, why is the next step so important? If you're not understanding that, I would say something now. Who does not realize why this next step is so important? Okay, because that is correct. Okay, now, in some cases, this does happen. Let's say you, for some reason, skipped this mole ratio. You might still have a chance of getting it correct. Why might that be? Because both coefficients are 1. I wouldn't, ammonia, I'm just going to put AN, okay? So remember, anytime you see a mole over a mole, look back at your equation. We see it's 1. So for every mole of ammonium nitrate, it's fine to do this as long as you remember that we've got 2 nitrogens and 4 hydrogens and 3 oxygens. So by that time, we've got what, 28 and 48, 4.04, 6, 16, 22. The mathematics addition here, look right. Okay, so then 80.06 goes here. From that of the atomic mass of all that put together. Oops, I wasn't supposed to cross that out. So take 33 times 80 times 44, and hopefully you get somewhere around 60. 60.01. Okay. All right. So what I want you to think about is, if you see a problem like this that you're working on, it's one of those things to where you really don't have to erase the whole thing, because some of these numbers are going to stay the same. So which 4 can stay, which 3 need to go? So we're still starting with this. This is still the atomic mass. That's for every mole. We needed to cancel that mole out, so those 4 can stay. These 3 needed to go. Okay, so now we're not looking for just grams of this. We want to know how many grams of water are, to say maybe given off, or how many grams of water are produced in this reaction. So this was part A. This is part B then. Okay. So everything is the same up to this point. Is still a mole to mole ratio, but instead it's water. Okay. We know nothing goes here because that was part of the previous problem. What about here? Okay. All right. So then I'm willing to bet, and it's just human nature, this is probably going to happen. Okay? Whether it's because maybe we're in a hurry or something to that effect, someone will put a 2 there. And it's how we learn. Because when mistakes are made, as long as we use it to benefit us. So when it comes to these mistakes, 1, learn from them. 2, to learn from them and then not repeat them. Yes. So now we take 33 times 36, well, 2 times 18. 33 times 36 divided by 44. Do we get somewhere around 2? Nope, looking at the wrong one, sorry. 27. Okay. Left side, are we on the bus? Middle, are we on the bus? Right side, are we on the bus? Okay. Well, is there anything that's just totally confusing you on this paper? Okay. Well, you have a little over 15 minutes. The rest of the time then is yours. Pick up with this tomorrow.